Hey guys, in this video we're going to have our NAV 213 EPlan 3C. So here's the scenario description. After the course lines have been laid on the charts like this, we have this course line. One of the truck will pass an underwater obstruction with a minimum distance for safe passage. The officer needs to determine the estimated time of arrival during passage of the underwater obstruction and the actual depth, as well as the underkeel clearance of about, we have a ship's loaded draught of about 10 meters and the ship's speed is 10 knots. And still the equipments that were needed is this one, the chart 1B and the chart 1A and the 1B. So still the same from the NAV 213 3A and 3B. Now we need to identify the underwater obstruction, the nearest one. So from here we can identify the obstruction. And here in the Diamante Rock, we have seen a rock awash. So it's one of our performance criteria that we need to identify. And also we have here the Virac bank. In the Virac bank we have a shallow water. So that will be also in the underwater obstruction. The first thing we need to do is to identify the distance of this whole plotted chart. So we have here a table which it includes the voyage of this EPlan 3C from Tacloban Point, this part, to the Cabugao Bay. So it has a total distance of about 141.3 nautical miles. Since we have to identify the distance of this Diamante Rock, this obstruction right here, so we have here in our table that in the Diamante Rock we have to travel about 74.4 miles. So 74.4. Since we have a whole distance of 141.3, so we need to subtract it with 74.4. Then we have 66.9, or about 67 miles we need to travel, or we have still 67 miles to go. Now with that 67 miles to go, I have here, so in the Diamante Rock, in order to get the time, we need to have we have a formula: time is equal to the distance over the speed of the vessel. So as I have said, lately we have a 67 distance, because I round it off, 66 mile, we have 67 miles. So the distance is 67 and the speed is 10 knots. It is in the initial condition of the EPlan. So time is equals to distance over 10 knots. So the distance is 67. 67 divided by 10 is equals to 6.7 hours. So this 6.7 hours, you can convert this to hours and minutes. This 0.7, we have to multiply it by 60. So we have 42. So this 6.7 hours, we have 6 hours and 42 minutes. But since on December 7, full away on passage, we have on 7 December 2020, we have 2 hours for the departure. So from this 6 hours and 42 minutes, we add this 2 hours, and then we had this time of arrival in that obstruction, 8 hours and 42 minutes. This is the estimated time of arrival in that underwater obstruction. So we identify the time of arrival in that obstruction, and then now we have to identify also in the Virac bank. Now the Virac bank is right here, so it's too far from our the initial course of our ship. Then we have in our table right here in this Excel, the Virac bank is about 3.9 to go. So 3.9. Again, we have a total distance of 141.3 minus 3.9. We got a 137.4. So I just round it off, so it's about 137. So we need 137 miles to go. And now I have right here in the Virac bank. So still time is equal to distance over the speed. Still the speed is 10 knots and the distance is 137.4 or 137 miles. So time is equals to 137 miles divided by 10 knots. 137 divided by 10 is equals to 13.7. So we have here 13.7 hours or 13 hours and again 0.7 times 60 is equals to 42. That's why we got 42 minutes. The departure is 13 hours and 42 minutes. Add to that 2 hours. Equal away on passage 2 hours. So we got 15 hours and 42 minutes. This 2 hours is in the initial condition on our NAV 213. So I'll just be reading this one. The vessel is about to depart from Tacloban Pilot Station of 11 degrees 27.5 minutes north and 124 degrees and 52 minutes bound to Kabugay Bay at 200 hours December 7, 2020. That's why we got this 2 hours. So estimated time of arrival of that obstruction is 15 hours and 42 minutes. And now we need to determine the height of the tide during the passage to the nearest underwater obstruction. This was just too easy. So first in the Diamante Rock. So again in the Diamante Rock, we have right here of 8 hours and 42 minutes. So 8. So we need our tide table. 8 and 42 minutes. Then we got 0.1 meters of the height of the tide. That will be in the Diamante Rock. And next will be in the Virac bank. This in the Virac bank we have right here. So the Virac bank we have 15 hours and 42 minutes. In this 15 hours and 42 minutes, so we just need to identify this in the tide table. And in the tide table we still got 0.1 meters of the height of the tide or HOT. And lastly, we need to determine the actual depth of the water during the passage to the nearest underwater obstruction. So first is the Diamante Rock. The Diamante Rock we have right here. The height of the tide is equals to 0.1 meters. Then the shape of the ship's drop is 10 meters. These 10 meters is still on the initial condition. I mean the ship's particulars in our NAV 213. Then still we have here the 0.1. This 0.1 is the height of the tide and this is the vessel. So as you have seen right here in our chart, we got here the lowest portion is the 48 or the nearest portion is 48. We have this datum right here, 48, as you can see, 48. So that will be the charted datum, 48 meters. So 48 meters plus 0.1, the height of the tide is equals to 48.1. 48.1. And again, we have 10 meters of the ship's drop. With this ship's drop, we can identify the under keel clearance. So 48.1 minus the ship's drop, 10 is equals to 38.1. That's why we have here a UKC of 38.1, and that will be on the Diamante Rock. The Virac bank we have a height of tide of 0.1 meters, and still in the condition of the ship is 10 meters draft. And we have to identify the charted datum or the datum here in a Virac bank bay. So we have here 46, as you have seen, 46, and then we add this 46 meters to 0.1, so basically we have 46.1 meters, and still we have a draft of 10. 46.1 minus 10 is equals to 36.1. The 36.1 will be the under keel clearance of our vessel in that particular obstruction. So 36.1 will be the UKC in the Virac bank. And lastly, we identify these things through the help of this table, and also with the use of our chart 1A and 1B. So that's all for this video, and I hope all things are clear. That would be all. Thank you. God bless.